In 2014, an architect in Phoenix named Christoph Kaiser completed the transformation of a 55-year-old grain silo into a livable home. The original structure, built in 1955, was 18 feet across and composed of corrugated steel, having stored grain for nearly 6 decades before Kaiser glimpsed a different potential within its walls. The interior spanned 340 square feet over 2 levels, featuring walnut and steel finishes that fit snugly within the cylindrical shell, with subterranean channels enabling passive cooling and a skylight that converted the vertical space into a natural ventilation shaft. The design functioned flawlessly. It was fully permitted. Residents could inhabit it. By law, it was entirely legitimate. Yet Kaiser had advantages most dreamers do not: detailed engineering plans, mastery of building codes, and a jurisdiction ready to approve unconventional materials under Section R104. 1500. Thousands of miles away in Montana, Kate Morris acquired a grain bin she saw as equally full of promise. But unlike Kaiser, her bins lingered empty for years. Transforming an agricultural container into a residence proved far from straightforward. Appraisers could not locate relevant, comparable sales. Lenders struggled to align draw schedules with construction steps, and insurers were at a loss to assess a property they could not categorize. The challenge was never the bin itself. It cost less than installing a standard garage door. The true obstacle was permission, the legal and bureaucratic labyrinth that blocked the path from silo to home. This story stretches far beyond modern agriculture, rooting itself in a much older architectural wisdom. Millennia ago, on the edge of a Scottish loch, ancient builders constructed circular dwellings on timber platforms raised above the water. Archaeologists recovered these homes, dating back 2,500 years, from the sediments below. The people who lived there were deliberate in their choices, selecting the circle for its efficiency. Circular walls minimized wasted materials, distributed structural loads evenly, and drew inhabitants toward the center, gathering life rather than scattering it into corners. These structures were not ornamental. They were lessons in practical physics, refined over generations. Scottish archaeologists documented roundhouses stretching from roughly the 8th century BCE through the early centuries of the Common Era. For centuries, circular domestic architecture was standard. Walls of timber, stone, and turf supported thatched roofs, while central hearths allowed smoke to escape naturally, radiating warmth evenly across every room without cold spots or dead zones. This timeless geometry persisted elsewhere. The Mongolian yurt, a circular home still in continuous use after over 1,000 years, demonstrates the enduring power of the circle. Researchers from Harbin Institute of Technology, Inner Mongolia University of Technology, and University College London in 2019 studied traditional felt yurts' indoor temperature and humidity patterns. Despite thin walls and large outdoor temperature swings, the felt effectively buffered humidity fluctuations, creating a livable interior. The circle was not an accident. It maximized usable floor area with minimal perimeter. Less perimeter meant less wall. Less wall meant reduced heat loss. And the math underlying this principle predates mortgages, building codes, and formal engineering alike. Civilizations from Scotland to Mongolia to the American plains independently discovered that the circle is ideal for structural integrity and efficiency. Grain farmers of the past did not reinvent the circle for homes. They applied it to storage, engineering robust cylindrical bins out of steel to withstand wind, weight, and time. Modern steel bins, built with 4-inch corrugated galvanized panels, can endure tremendous stress. Their tensile strength can reach 70,000 C, with roof peaks rated to handle loads of up to 10,000 pounds. Companies like Sioux Steel manufacture these agricultural giants in diameters from 15 to 60 feet. These are not simple garden sheds, but engineered containers designed to hold harvests safely. The challenge never lay in the shell. It is inherently strong and honest. Bare steel conducts heat rapidly, so without insulation, interior walls cool below the dew point, condensing moisture and creating a sweating surface. The real breakthrough comes from closed-cell spray polyurethane foam, as outlined in Joseph Lusterek's 2021 update via Building Science Corporation. Spray foam can simultaneously control water, air, vapor, and heat. When bonded directly to the steel surface, it seals every seam, bolt hole, and corrugation ripple. Just a 2-inch layer delivers roughly R12 to R14, while 3 inches approaches R20. Suddenly, a cold metal cylinder transforms into an insulated airtight envelope, redefining the possibilities of living inside a grain bin. Yet, even with perfect materials, code compliance remains the final hurdle. The International Residential Code in Section R316 governs these adaptations, ensuring that the physics proven over thousands of years meets modern standards. The circle works, the steel endures, and with careful insulation, the old agricultural form becomes a contemporary, livable home. History, physics, and ingenuity converge, a shape perfected in ancient Scotland, preserved on the Mongolian steppes, and rediscovered on American farms, now offering a path to legal, comfortable, and sustainable dwellings. Building codes require that foam plastic insulation be shielded from direct contact with the interior of a home by an approved thermal barrier, usually a 2-inch layer of gypsum board. The sprayed foam against shiny steel cannot serve as the final surface in a livable space. The regulation insists on an intermediary layer, separating occupants from combustible insulation. This is not about limiting performance, it is fire protection. The difference is crucial. The cylindrical form retains its physical advantage. It offers less wall surface per square foot of interior space. No corners accumulate cold. The geometry naturally preserves warmth. Christoph Kaiser, the Phoenix architect who converted a 1955 grain silo into a 340 square foot home, described the interior as a sanctuary where abundant natural light creates comfort that nourishes the spirit. His words were not mere flourish. They reflected careful engineering. The silo dwelling was intentional, a precise answer to a simple question. What if the most affordable and strongest shell could also be the most thermally effective shape? Kaiser's solution included a 2-story interior, subterranean ducts for passive cooling, and an operable skylight turning the cylinder into a natural ventilation shaft. The steel shell itself costs less than a suburban garage door. The expense lies elsewhere: foundation work, waterproofing, custom openings, interior framing, mechanical systems, and navigating code approvals. The steel is cheap, but gaining permission is costly. The grain bin house was not banned. It was designed out of existence. Take West Valley City, Utah, where building codes forbid corrugated metal and exposed fastener siding on exteriors, not for structural reasons, but for appearance. Phoenix design guidelines demand that pre-engineered metal structures visible from streets or neighborhoods incorporate significant alternative materials: brick, stone, stucco, or masonry. In effect, the strongest, most wind-resistant agricultural shape fails the aesthetic hurdle before the first permit application is filed. The corrugated cylinder is not unattractive, it is simply unfamiliar. And in zoning language, unfamiliarity translates into nonconformity. Beyond aesthetics, the International Residential Code section R104. 11 permits alternative materials, methods, and designs, but only if a building official approves them based on submitted evidence. The onus is entirely on the applicant. Proof of equivalence is required. Engineering studies, testing data, and documentation must convince a reviewer who has never encountered the assembly before. The code does not say no, it says demonstrate it. Yet proving equivalence demands money, time, and expertise that most homeowners cannot afford. Regulations were drafted for rectangles. Aesthetic guidelines reward familiar materials. Approval systems favor repetition and penalize novelty. No explicit ban on grain bin homes exists, yet the process effectively does the same through procedural complexity. Appraisal hurdles compound the challenge. Fannie Mae guidelines allow valuation of unconventional homes only when an appraiser can locate comparable sales and establish a credible market value. In most markets, no recent grain bin transactions exist within reasonable distance. The home might be sound, energy efficient, or visually striking, but without comparables, lenders cannot issue loans. Kate Morris in Great Falls, Montana, purchased a bin envisioning a unique home only to see it sit idle for years. Transforming a steel cylinder into an insured code-compliant dwelling proved far harder than acquiring the shell itself. Architect Nick Poncho eventually designed the interior, while builder Tom Scavron, experienced with grain bins in youth, constructed a home within one as an adult. Poncho called the result remarkable, a space both simple and utilitarian, a place imbued with a kind of quiet magic. The magic was real, but the process was punishing. Construction lenders require draw schedules tied to conventional stages: foundation, framing, roof, mechanical systems, finishes. Grain bin conversions do not follow these sequences. Framing and roofing differ, and lenders' checklists do not match. Every payment requires explanation. Every explanation demands documentation. Each cycle consumes additional weeks. Insurance poses similar challenges. Non-standard materials and assemblies fall outside conventional underwriting models built for wood frame construction. A steel cylinder insulated with spray foam and finished with gypsum does not fit standard pricing models. Some owners find coverage through specialized carriers, some accept higher premiums, others self-insure and hope for the best. The economic logic is not a conspiracy, it is system optimization. The American housing infrastructure, codes, appraisals, insurance, lending, was engineered to process a single product efficiently. Above-ground wood frame rectangular homes in the United States saw approximately $9.5 billion in residential construction spending in 2012. The system is optimized for that model. It does not reject grain bins. They simply lie outside its vision. Raymond Sterling, director of the Underground Space Center at the University of Minnesota, documented that code obstacles and financing barriers, not structural failure, occupant dissatisfaction, or engineering limits, remain the primary impediments to broader adoption of unconventional housing. The material can endure. The design can function. The barriers are procedural, financial, and cultural, an invisible cage that keeps the strongest, most efficient forms of architecture from widespread use. The structures themselves functioned flawlessly, yet the broader system failed to acknowledge them. Codes were written to favor aesthetics that excluded agricultural steel. Appraisal frameworks demanded comparable sales. Lending was structured around draw schedules designed for traditional stick-frame construction. Insurance underwriting relied on assemblies already familiar to the industry. This created a housing economy in which America's cheapest, strongest shell required the priciest approvals. The obstacle was never the steel, it was the paperwork, and that challenge persists today. Christoph Kaiser did not wait for the housing industry to grant approval. He sought authorization from the city of Phoenix, supplied all necessary engineering documentation, complied with the code, and built anyway. Completed in 2014, his silo home transformed an 18-foot diameter, 1955 grain silo into a 2-story, 340-square-foot dwelling with vertical walnut and steel interiors, subterranean cooling ducts, and an operable skylight. The home stands today, fully occupied and legally recognized. Kaiser's vision became a beacon. It demonstrated what is possible when permission aligns with engineering. While many silo homes exist, the elegance of the cylinder often falters if the interior execution fails to match. The shell itself is rarely the obstacle. It is the interior design, the thermal envelope, and the navigation of code that present the true challenge. In Montana, Kate Morris and Nick Poncho reached the same conclusion through a different route. Their project was not a compact desert dwelling, but a full-scale home on rural land. Poncho treated the interior as a self-contained, insulated volume, nested within the metal shell, while Skavron built inside what he once stored as grain. The finished house proved the dream feasible. The years of delay illustrated that the system, not the materials or design, obstructed progress. International comparisons sharpen this point. In the United Kingdom, grain silo conversions routinely receive planning permission. In Denmark, the architectural firm Cove converted a former grain silo into a combination of residential and public spaces, demonstrating that the form itself is credible. France has recognized professional standards for hemp lime construction for over 25 years. This material, sometimes called hempcrete, provides hydrothermal performance that traditional resistance-based calculations fail to fully capture. In 2015, Oliver Kinane and colleagues at Queen's University Belfast published research showing that hemp lime walls exhibit high thermal inertia, mitigating limitations apparent in simple R-value metrics. The 2024 International Residential Code introduced Appendix BL specifically for hemp lime construction, a milestone granting a prescriptive code path rather than requiring alternative means approval. Steel grain bins lack such an appendix, not yet. Practical paths exist for these homes, but they demand careful navigation. A used grain bin shell may cost a few $1,000s. A new one is pricier. Completing the home, foundation, waterproofing, custom openings, insulation, thermal barrier, interior finishes, mechanical systems, and specialized millwork carries the real expense. The steel itself remains cheap, but the finished house reflects the cost of translation from industrial container to permitted, habitable dwelling. What shifts is not just the upfront price, but operating costs, durability, and long-term ownership math across decades. Grain bin homes were deliberately designed out of conventional approval paths. Shipping container homes encounter similar aesthetic resistance. Barn dominiums face insurance hurdles. Straw bale construction spent decades seeking code recognition, while earth-sheltered homes still require variances for egress and daylight. The pattern repeats. Building methods that challenge convention face structural friction from systems built to favor uniformity. These homes are more than alternatives. They are lessons in efficiency. A grain bin resists wind better than wood. It encloses interior space with minimal wall area, reducing heat loss. Its geometry, proven over 3,000 years in Scotland, Mongolia, and the American prairie, remains unchanged. Yet the housing system often cannot see its value. The technique functions perfectly. It is the stacked layers of approval that fail. Authorities rarely explain that the strongest residential form in American agriculture mirrors what humans have used for millennia. Few highlight that the steel shell costs less than a garage door or that section R104. 11 provides a legal route for alternative materials, if one can afford to prove equivalence. The steel itself is not the problem. The cylinder is a form built to endure. It holds grain against wind and time and gathers life around a central core instead of scattering it into corners. Its walls are minimal, reducing heat loss, and its structure stands firm in storms. Thousands of these silos already exist across the American Midwest, waiting to shelter something beyond harvest. Corrugation, tensile strength, and load distributing geometry remain unchanged. The only difference is the knowledge and recognition of permitting authorities. A shape lawful for storing corn is often not recognized for family habitation. A material approved for livestock is not automatically accepted for living spaces. A steel shell can support 10,000 pounds at its peak, but cannot carry the bureaucratic weight of being labeled residential. This is not merely alternative housing, it is original housing. The rectangle is the deviation. Every share of this knowledge preserves forms that the housing system once sought to erase. It reminds us that the cheapest, strongest, and most enduring shapes already exist, waiting for vision, permission, and a willingness to navigate the system. Next, the exploration continues underground. A home that eliminates the heating bill and the codes that cannot approve dwellings with too few windows. Earth-sheltered construction reaches back 5,000 years to Cappadocia, where the archive of ancient ingenuity opens once more. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.